Hi, this is Professor Jim Chen at California State University, Long Beach. In this video lesson today, we'll look at how to use the vertical line test to determine whether or not a curve on the plan defines a function. Call that a function is a rule that assigns a unique output to each input in a domain. Pictorially, this corresponds to drawing one and only one y value for every x value. For example, if you look at the graph of f of x equals x squared, which is a parabola that looks like this. Notice that for each x value we pick on the x-axis, it corresponds to a single y value on the curve. Same thing happens on the negative side. For each x value I pick, I get a single corresponding y value on the curve. X squared corresponds to a function. So in this case, I could say that the graph here defines a function. On the other hand, the curve of x equals y squared looks like the following. Where let's look a little bit closely why the graph looks like that. The equation here is written x equals a y squared, which means x value depends on the y value here. So when we construct a table, I'm going to choose the y values and then calculate x accordingly. For example, choose y equals 0, then x will be y squared, which would be 0 squared. When y is equal to 1, I get 1 squared, which is also 1. When y is negative 1, I get negative 1 squared, which is positive 1. When y is 2, I get 2 squared, which is 4. When y is negative 2, I get negative 2, the quantity squared, which is also positive 4. Let's now identify those points on the curve given here. First order pair is 0, 0. You have to be careful. You're going to list the x value first and then the y value second. The second order pair of points here is 1, 1. The third order pair of points is 1, negative 1. Notice again, you list x value first. Fourth pair of points here is 4, 2, and the last order pair of points here is 4, negative 2. After carefully labeling all the points, this is what we get. Did you notice that, for example, when x is equal to 4, it actually has two different corresponding y values associated with it, namely the positive 2 here and the negative 2 here. Hence, we say that x equals y squared does not define a function. Or we say that the graph of x equals y squared does not represent a function. So notice the keyword graph and the function here. Did you notice that checking whether or not a graph defines a function in those two examples can actually be accomplished by drawing a vertical line at a general point through the graph? Here, if I were to draw a vertical line at the point x equals 4, we notice that this vertical line intersects the curve, or the graph of the curve, at two distinct points. If you were to draw a vertical line at a general point in this graph, we notice that it only intersects the graph at a single point. The definition of function gives rise to a graphical test that is called the vertical line test. The test states the following. A curve in the coordinate plane is the graph of a function if and only if no vertical line intersects the curve more than once. I'm going to pay close attention to this last sentence here. No vertical line intersects the curve more than once. What this means is that if you were to draw a vertical line at a random point through the curve, it could intersect nowhere. It could intersect once, but it cannot intersect more than that. 0 and 1 is fine, but anything that's bigger than 1 is not acceptable in order for it to be a function. Now let's look at a few examples next. Which one or ones of the following curves represent a function? Pause the video and take a moment to think about this yourself using the vertical line test. The answer is B. This is the only graph that actually represents a function. The reason why is because of the following. If you look at the first graph, if we were to draw a vertical line here, it would intersect the graph at points here. You could have vertical line here that intersects the graph at 0 point. That's okay, but as long as you can find one vertical line through the graph that intersects more than 1 point, it fails to be a graph of the function. Right away, part A is not a function. If you look at part C here, you can draw a vertical line through the graph. It intersects at 1, 2, and 3 points. It could also intersect just one point here. Remember, as long as you can find one vertical line that intersects the graph at more than one point, it fails to be graph of a function. B is the only graph that represents a function because regardless where I draw the vertical line, it would never exceed one intersection. If I do another vertical line here, I have one intersection. I do another vertical line here, only one intersection. Notice that in the case of the non-function example, like for example in part C, sometimes a vertical line can intersect at just a single point, like in the case here, or sometimes a vertical line can intersect at more than one point, like in the case of this vertical line here intersects at 3 different points. But as long as there is one vertical line that intersects the curve at more than one point, the graph fails to represent a function. Second, notice that the functions always come from equations that can be written as y equals something, like the case in part B. You might recognize that the equation for part B is y equals x cubed, or something similar to that modified by a scalar. Here we can actually write y on the left-hand side as the only variable in terms of an expression in x. But in part A, which corresponds to a circle equation, say for example x squared plus y squared equals 1, if we were to try to solve for y in part A, we would get something like the following. Well, y squared, 1 minus x squared, and then we have to take square root both sides. But when we take square root, we get plus or minus, which means that I have to write y as plus or minus square root of 1 minus x squared. The fact that you actually have plus or minus tells you there are actually two different values for each x value you put in. Imagine picking a single x value here, you will always get two different y values associated with it because of the plus or minus sign. That is why it fails the vertical line test.